Imagine being in a place where the sky is not blue, but a deep crimson. This is because some planets have atmospheres that scatter light in different ways, making their skies appear in various colors. On Mars, the sky can appear more hazy and red due to the presence of iron oxide particles. This unique phenomenon is a result of the planet's geological composition. The iron oxide particles are a product of the planet's rusty red soil, which is rich in iron and oxygen. Did you know that there's a giant storm on Jupiter that has been raging for centuries? This storm, known as the Great Red Spot, is so massive that it could swallow several Earths whole. The storm's incredible size and durability are due to Jupiter's unique atmospheric conditions, which create strong winds and storm systems. The Great Red Spot is a persistent anticyclonic storm, meaning that it's a high-pressure region with clockwise rotation. This rotation creates a self-sustaining system that allows the storm to persist for centuries. Space is filled with mysterious sounds that are inaudible to the human ear. These sounds are created by electromagnetic waves that emanate from various celestial objects, such as stars and black holes. By converting these waves into sound waves, scientists can hear the eerie sounds of space, which can be likened to a cosmic symphony. The sounds are often described as whispers, creaks, and groans, and are a result of the intense energy released by these celestial objects. This energy is then converted into sound waves, allowing us to hear the universe in a way that's both fascinating and unsettling. The Andromeda Galaxy is approaching us at a speed of around 250,000 miles per hour. In about 4 billion years, the Andromeda Galaxy will collide with our own Milky Way galaxy, resulting in a spectacular cosmic collision. This collision will not be a direct crash, but rather a gradual merger of the two galaxies, which will take hundreds of millions of years to complete. The merger will result in a new, larger galaxy with a unique structure and composition. The collision will also trigger the formation of new stars and planetary systems, as the galaxy's gas and dust are perturbed and compressed. There's a type of star called a neutron star that's so dense, a sugar cube-sized amount of its material would have a mass of about 1 billion tons. Neutron stars are formed when a massive star undergoes a supernova explosion, causing its core to collapse into an incredibly dense object. This density is a result of the star's core being compressed into an incredibly small space, creating an object with an enormous amount of mass and gravity. The neutron star's density is so high that it warps the fabric of space-time around it, creating an intense gravitational field that can affect the motion of nearby objects. The International Space Station orbits the Earth at an altitude of around 250 miles. It's so close that if you were to throw a ball straight up from the surface, it would take only about 5 minutes to reach the space station. The space station's orbit is a result of its velocity and altitude, which allow it to balance the force of gravity with the centrifugal force of its motion. This balance allows the space station to maintain a stable orbit, making it an ideal location for scientific research and experimentation. The space station's proximity to Earth also makes it an important platform for studying our planet and its atmosphere. The universe is still expanding, and this expansion is accelerating. This means that galaxies that are currently moving away from us will eventually be moving away from us even faster. The expansion is a result of the universe's dark energy, which is a mysterious component that makes up about 68% of the universe's total energy density. The dark energy's negative pressure causes the universe's expansion to accelerate, resulting in an ever-increasing distance between galaxies. This acceleration will eventually lead to a point where the universe's expansion becomes so rapid that it will be impossible for us to see or interact with distant galaxies. There's a giant black hole at the center of the Milky Way galaxy, with a mass of approximately 4 million times that of our Sun. This black hole is so massive that it warps the fabric of space-time around it, creating a region from which nothing, not even light, can escape. The black hole's gravity is so strong that it dominates the motion of nearby stars and gas, creating a region of intense gravitational influence. The black hole's presence also affects the formation and evolution of stars in the galaxy, as its gravity can trigger the collapse of gas and dust into new stars. The cosmic microwave background radiation is the oldest light in the universe, dating back to the Big Bang. This radiation is a result of the universe's initial heat and energy, which has been cooling and expanding over billions of years. The cosmic microwave background radiation is a snapshot of the universe when it was just 380,000 years old and provides valuable insights into the universe's composition and evolution. The radiation's patterns and fluctuations also provide clues about the universe's fundamental properties, such as its density and curvature. Astronauts who spend time in space can grow up to 2 inches taller due to the lack of gravity. This is because the spine expands when it's not being compressed by the force of gravity, allowing the vertebrae to move apart and increase the overall height. The lack of gravity also affects the body's fluid distribution, causing fluids to shift towards the upper body and resulting in a range of physiological changes. The increased height is a temporary effect, however, as the spine will return to its normal length once the astronaut returns to Earth's gravity. There's a type of asteroid called a Trojan asteroid that orbits the Sun in the same path as Jupiter. These asteroids are trapped in a stable orbit, known as a Lagrange point, where the gravitational forces of the Sun and Jupiter balance each other. The Trojan asteroids are thought to be remnants from the early days of the solar system and provide valuable insights into the solar system's formation and evolution. The asteroid stable orbits also make them ideal targets for future space missions, as they can provide a unique opportunity to study the early solar system's composition and dynamics. The largest planet in our solar system, Jupiter, is so massive that it makes up about 2.5 times the total mass of all the other planets combined. Jupiter's massive size and stormy atmosphere make it a fascinating subject for study, and its unique composition provides insights into the solar system's formation and evolution. The planet's massive size also affects the surrounding space, creating a region of intense gravitational influence that shapes the orbits of nearby planets and asteroids. Jupiter's massive size and gravitational influence make it a dominant force in the solar system, and its study can reveal valuable information about the solar system's history and dynamics. Which of these mind-blowing facts about space surprised you the most? Was it the giant storm on Jupiter, the mysterious sounds of space, or perhaps the massive black hole at the center of the Milky Way? Whatever it was, space is full of incredible secrets and wonders waiting to be explored and discovered. The universe is a complex and fascinating place, and by studying its many mysteries, we can gain a deeper understanding of our place within it and the secrets it still holds. So, keep looking up at the stars and wondering about the incredible universe we live in, and who knows what other amazing facts we'll discover in the future.